Good morning on this dark and rainy morning today. And I'm going to go ahead and record or film the next lesson. And this is all about, again, it's under geometric figures. And we are going to talk about transversals, angle relationships, and triangles today. So, our learning target, I can find the measure of interior and exterior angles in a triangle by using relationships between these angles. And there are several words we are going to learn. And we have exterior angle, interior angle, line segment, remote interior angles, triangle, vertex, etc. And so, based on this vocabulary, it'll make sense when we are talking about the transversals angle relationships. All right. So, let's first talk about what is a line segment. Okay, so that's the first thing. So I've drawn three triangles. We'll talk about what a line segment is. And a line segment is part of a line containing two endpoints and all of the points between them. And a triangle is formed by three line segments. Okay, three line segments. And how do we write a line segment? A line segment is basically written using a segment notation. Okay, for example, if I have this part, all right, so xy is written like this is written like this. All right. So therefore, that is the segment notation, and it is read as segment XY. Segment XY. Okay. Let's look at this one. So this is another line segment. Okay. So this is going to be this side. So remember, this is the side. Okay. So we're talking about the sides right now. Talking about the sides right now. And this side is going to be what? This side is YZ. Okay. This is YZ. And it is written like this. And that is telling you that that is segment YZ. Okay. This one, let's look at here. And then we have this part. Okay. So that is also, of course, a segment. And so this is written as segment XZ. And then you have that line on the top. That's telling you that it's the segment. So we are talking about the sides right now. Okay. So that's the first thing, is knowing what a line segment is. Now let's do where are the vertex over here, or the vertices. Okay, so a point where the segments intersect is a vertex. And so let's look at what the vertex is. So this one is vertex X, because the lines are intersecting over there. All right, this one is vertex Y, and this one is vertex Z. This is vertex Z. All right. And so once again, let's quickly talk about what is a vertex. All right. So a point where the segments intersect is called the vertex. So where they're intersecting. So these are intersecting. Over here, these two are intersecting. Here, these two are intersecting. So that is the vertex. Okay. And then the next thing in a triangle, we've got to know what are the interior angles. Okay. So the three angles that lie inside a triangle formed by the segments and the vertices are called interior angles. Okay. So we know that, one is vertex and more than one is going to be vertices. So that's why I said vertices. Okay. Now let's look at which ones are the angles over here that is formed. And the first one here, this is going to be this one. This is angle X. And the angle is written like this. That's telling you it's an angle. This one is angle Y, and this one is angle Z. Okay, so this is a basic quick review of the vocabulary words, so which were we talked about what the interior angles are. These are my interior angles. We talked about what the line segments are. These are the line segments. And then we talked about, of course, the vertex and the XYZ. XYZ, these are all the vertices. Okay, now let's move on, and we are going to talk about what is the measure of the interior angles of a triangle. Okay, and so if we have a triangle, I need you to understand, and I always like to explain in the form of a quadrilateral. Okay, so let me make this a little clear. So let's say we have any quadrilateral. Okay, and in a quadrilateral, what angles do we have in the corners? We can see that these are all right angles, right? So these are all right angles. That means 90 degrees, each of them. 90 degrees, 90 degrees, and 90 degrees. Okay, so what is 4 times 9? That is 36, and the 0. So that gives me actually 360 degrees are in a quadrilateral. Any quadrilateral has 360 degrees. Okay, now let's see what happens when I split it in half either way. Okay, so look, I'm just going to take this and I'm going to split it in two. So what is that? Now we have two triangles in a quadrilateral. So what is 360 divided by 2? And I get what? 180 degrees. 180 degrees. So this is 180 degrees. This is 180 degrees. All right. So because this becomes 90, split over here, this is 45 and 45. So every quadrilateral, just think of it, there are two triangles in a quadrilateral. So this really helps you remember, because we have 360 with the 4 right angles. And so now in a quadrilateral, we have two triangles. So because of that, each triangle internal measure is 180 degrees. When we add up angle X plus angle Y plus angle Z, I will always have 180 degrees as the internal measure or the interior measure of the triangle angles. Okay, so the interior angles of a triangle are always equal to 180 degrees. So let me go ahead and show you a quick picture. Okay, and this is the flag, and as we can see, we have three different angles showing up over here. It's asking find the value of X in the flag of St. Kitts and Nevis. Okay, so we are going to look at the angles over here, and so we are trying to find the value of X. So look, this is a triangle. All right. And if I have this over here, what does this mean? This means that this is a 90-degree angle. All right. And so it's saying find the value of X. So we are going to first write an equation, because X plus what? Plus 56 plus 90 over here. So all three angles in a triangle, as we just said, are equal to 180 degrees. So this is equal to 180. Okay. And so if that is equal to 180 degrees, now we are going to combine the like terms, and these are the like terms. So this is going to give me X plus 146 is equal to 180. And then we are looking at this, and this we are going to use the subtraction property of equality. And so we are going to subtract 146 from both sides of the equation. And so this is 0, and x is equal to 180 minus 146, and I get 34. So this angle is equal to 34 degrees. Okay? And let's do another problem really quick. Um, just to understand what the angle measures will be. And here, like, if I substitute the value for x and I do 34 plus 56 plus 90, I will see that it is 180 degrees. So then you are correct. If it is less or if it's more than 180 degrees, you made some calculation error and you want to check your work. Okay, so let's do one more problem. And let's look at this. All right, so it's asking, sorry, what is the value of x in the doghouse shown? So again, as we can see, that is a triangle over here. Right? So that is a triangle over here. And what is the value of x? So we are going to do, please don't like just automatically go by the shape. If it looks like an equilateral triangle or isosceles triangle or scalene triangle, you still need to do the calculations, because sometimes figures are not drawn to scale. Okay? So just want you to be aware of that. So let's look at this. This is x plus 86 plus 47. We know that when I combine these three, I am going to end up with 180 degrees. Okay, I'm going to end up with 180 degrees. So first I am going to combine the like terms over here. So that means 86 plus 47. And what is 7 plus 6? That is going to give me 13. Carry over 1, right? And so 8 plus 4 is 12 plus 1, and I get 133. Okay, and so that means x plus 133 is equal to 180. And then I am going to subtract 133 by using the subtraction property of equality from both sides of the equation. So minus 133 minus 133. Okay, and so therefore this is x is equal to, can I take away 3 from 0? No, so I'm going to have to borrow. This becomes a 7 and this becomes a 10. What is 10 minus 3? That is 7. And what is 7 minus 3? That gives me 4, and 1 minus 1 is 0. So x is equal to 47 degrees. This is equal to 47 degrees. All right, so that's how we calculate the third part. So obviously by looking at this, I can see that two of the angles are congruent. So that is an isosceles triangle. Okay. Because in an isosceles triangle, what we have? We have two angles and two sides that are congruent to each other. All right. Now, let's go over some other vocabulary words now. But first I need you to, before we do that, let's quickly talk about how we can also use ratios to calculate the angles. All right, so let's say I have a triangle ABC. Okay, let's say I have a triangle ABC. All right, and again, please remember that things are not always drawn to scale, so I don't want you to be confused by that. Let's say I have something like this. Okay, all right, let's do something like that. And the measure of angles ABC, okay, so measures of angles A, B, and C are in the ratio of 1 is to 4 is to 5. So 1 to 4 to 5, and that is my ratio. And so we need to find the measure of each angle. Okay, so we are going to let x, angle A, is going to be represented as x. Okay, and then since angle B is 4 times greater, because it said ratio is 1 to 4 over here, so angle B, since that is 4 times greater, we are going to say that is 4x, and angle C is going to equal, since it's 5 times, I'm going to say is 5x. Okay, and so once I have this set up, I can write an equation and then I can solve it, because I know that the internal angles, the sum of the internal angles is going to be how much? 180 degrees total, right? So I'm going to do x plus 4x plus 5x is going to give me 180 degrees. So I'm going to write out my equation like this, and then I'm going to solve it. Okay, so these are all like terms. So that means I can add them. So x plus 4x is 5x, and 5x plus 5x gives me 10x is equal to 180. And then opposite of multiplication, because 10x, that means 10 times x, is division. So I'm going to use the division property of equality, and I'm going to divide both sides by 10. 10 divided by 10 gives me 1. 1 times x is x. And 180 divided by 10 is 18. So it tells me that this angle is 18 degrees. Okay, so if that is 18 degrees, we can easily calculate what the other measurements are. So the next one, let's say angle B, it said 4 times x. So we are going to do 4 times 18, which is going to give me 72 degrees. Okay, because this is what did I do? If x is 18, this is 4 times 18, and this is 5 times 18. Angle C is 5 times 18, which is going to give me 90 degrees over here. This is 90 degrees. All right. And so that's how I find all the missing values. Now, if I were to add 90 plus 72 plus 18, I will end up with 180 degrees for you to check your work, whether you calculated it correctly or not. Okay. So that's how we find angle measures using ratios. Now, we've talked about interior angles. Now, let's quickly discuss what exterior angles are. Okay, so, all right. So, if I draw a triangle like this, okay, and I say 1, and I can say this is 3, and this is 2. Okay, now let's look at this. These are my interior angles because they are inside, right? Then the triangle also has exterior angles formed by one side of the triangle and the extension of the adjacent side. So extension here. And we can just go ahead and do all the extensions of the adjacent side. Okay, as you can see what I'm doing. And then I can pull this down like this. All right, now let's look at this. So inside, these were the interior angles. These were the interior because they are inside. Okay, and then as I said, exterior angles are formed by one side of the triangle and the extension of the adjacent side. So let's say this is 6 and this is angle 5, and that is going to give me angle 4 over here. Okay, so these ones which are outside, these are called the exterior angles. These are the exterior angles. All right, so in what I just drew over here, angles 4, 5, and 6 are the exterior angles, and an exterior angle is supplementary to its adjacent interior angle because the two angles form a straight line. So once again, just let's quickly recap. What are supplementary angles? Supplementary angles are two angles that when you add them up, you are going to get 180 degrees. So as I just said, that if I add this and this, what do I get? I get 180 degrees because it's a straight line. If I add this and this, I get 180. If I add this and this, I'm going to get 180 degrees. Okay, so angle for um, and angle 1 are going to form 180 degrees. That's what I'm saying. Angle 3 and 5 are forming 180 degrees. Angle 2 and angle 6 are going to be forming 180 degrees. Okay. Now, each exterior angle of the triangle has two remote interior angles that are not adjacent to the exterior angle. Okay, so let's look at angle 4, for example. Let's look at this angle. All right, so angle 4, if we look at that, which ones are going to be the remote interior angles that are not adjacent to the exterior angle? It'll be these ones, this one and this one, because these are not adjacent. All right, so these are called the remote, these are called the remote interior angles, remote interior angles. All right. Okay, remote interior angles. And so let's look at angle 5. Which ones are going to be the remote interior angles? So it's not adjacent. So for angle 5, remote interior angles are going to be 1 and 2. Angles 1 and 2 are going to be for angle 5. Which angles are remote angles for angle 6? So here's angle 6, not adjacent. So these ones, 1 and 3, are the remote interior angles for angle 6. Okay. So one thing you also need to remember that the measure of an exterior angle of a triangle, okay, so measure of an exterior angle of a triangle, okay, um, it is equal, this is equal to the sum of the two remote interior angles. So this is one thing, please remember. Okay, the measure of an exterior angle of a triangle is equal to the sum of the measure of its two remote interior angles. So this value, this angle is equal to these two angles added up. This angle is equal to these two remote interior angles added up. This angle is equal to angle 1 and angle 2 added up. Okay, so that's what this means. So let's talk about a quick question, and I am going to go ahead and draw another triangle. Okay, let's draw it like this. Let me do just going to make this like this, okay? And I'm going to say this is 60 degrees, this is 55 degrees, and this is 65 degrees, okay? And then this is angle A, angle B, angle C, okay? And then I have this one as 115 degrees, if that is given to me. Remember, this is my exterior angle. And then these two angles, this one and this one, are my remote interior angles. Remote interior angles. Okay, so let's look at that. I know that 60 plus 55 plus 65. So let's look at this one. I know that within a triangle, uh, the interior angles is 180, right? So look, 55 plus 60 plus 65 is going to give me 180 degrees. All right. So now when I'm talking about supplementary angles, supplementary means when they are here right next, next to each other like this, and it's on a straight line. Okay, that is also going to give me 180 degrees, right? Because it's a straight line. So look, 65 over here, okay, plus the 115, which I should have written a little bit this side. Okay, so 65 plus the 115 is also going to give me 180 degrees. Right? So what I'm going to do is I'm going to go ahead and write out this equation. All right. So which is the first one? What was the first equation? This is equal to this. That's basically what I'm trying to say. Okay. So that one is equal to this one. So I have 55 plus 60 plus 65. This part is 180, right? But this is also 180, the supplementary. So this is equal to 65 plus 115, because both of these are equal. They are both equal to 180, right? So I've written out the equation, and then what I'm going to do is I am going to subtract 65 from each side, because this one, okay? So minus 65 minus 65, okay? And so what am I left with? What am I left with? I'm left that 115 is equal to 115. So that's the exterior angle, okay? So we have 115 over here is equal to 115 here. So that is the value of that 115, which is what? This and this combined is equal to this. And that's what I just wanted to show you that. Okay? Now, let's do an example to find the exterior angle. Okay? So I will take you back to the board for this one. Give me a second. And let me get out of here. All right. So I skipped this one. And here we go. So if I look at this, and I am going to make this full screen so you can see properly. All right. So here's my question. In the beach chair shown, okay, in the beach chair shown, angle M, the measure of angle 2 is 55. Okay, so this one here is 55 degrees. And angle 3, this is 60 degrees. All right, find the measure of angle 1. So that's literally what I just did, okay? Because we know that the measure of angle 2 plus the measure of angle 3 will equal to the measure of angle 1, because the sum of the two remote interior angles is equal to the exterior angle measure, right? So what is angle 2? This is 55. What is angle 3? It is 60. Okay, this will equal to the measure of angle 1, and that gives me 115 is equal to the measure of angle 1. All right, so just showing you based on a word problem or whatever is provided to you. Okay, so let's do another one, and that'll be the last problem to practice. So here we go. We are going to do, let's do this one. Okay, example 4. All right, so look what it's saying. It is saying that in the figure, measure of angle 4 is 135. So it's telling me this one is 135 degrees. Okay, find the measures of angle 2 and angle 1. Find the measures of angle 2 and angle 1. So now we know that the measure of angle 2, right? And so measure of angle 2 plus measure of angle LKM. LKM is going to give me measure of angle 4. Going to give me measure of angle 4, because the two remote interior angles, sum of that is equal to the exterior angle. So we know that this part, this is what? 90 degrees, right? So we have measure of angle 2 plus 90 degrees is equal to measure of angle 4 is 135 degrees. Okay, and so then when I do the subtraction property of equality, I can just subtract 90 from both sides. Okay, and so when I do that, I get angle 2 is equal to 135 minus 90, and I get 45 degrees. Okay, so angle 2 is going to be 45 degrees. And so as you can see, this is how literally in this lesson, which is all about the transversals angle relationships, just remember what the terms are, how the exterior angle is, the same measure as the sum of the two interior angles. You've got to remember that the interior angles, if you're just calculating the sum of them, then that is equal to 180 degrees. You've got to know the vocabulary, vertex, the line segments, and of course, we know what a triangle is. But this is basically how we use relationships in order to calculate the unknown value. All right. Have a great day, everyone.